So what you're going to be asked to do in your practice is to be able to know whether a list of numbers, a sequence, is an arithmetic sequence, a geometric sequence, or it just doesn't fit either of those patterns. There are several ways to check. Here's what I think is the easiest. I like personally to make a table of these different values. And I'm going to put two things in the table: the term number. And so here there's 1, 2, 3, 4, 5 numbers listed. That means there's the first term, second term, third term, fourth, and fifth. So first, second, third, fourth, and fifth. And then the other thing I'm going to list is what the actual value is. So it was a 3, and then an 18, and then a 108, a 648, and a 3888. So 3,888. Now, the term number, we're not going to use in the calculation, at least not today. But going forward, it is going to be important to know what term numbers you're dealing with. That's why it's a good practice now. Now, I would then suggest, let's just take a look here and do a little bit of investigation first. So for example, let's just estimate the difference. So 3 and 18, those are not that far apart. But 18 and 108, those are very far apart. So we're probably not adding the same number each time to get from term to term. Now, you should double check that. So the way to check is to see what you added to go from term 1 to term 2. You're always going to take the bottom number minus the top. So 18 minus 3 means that I had to add on 15 to get from the 3 to the 18. Now check the next one. We're looking to see if we get the same difference or not. So 108 minus 18. I'm going to actually use my handheld calculator here. So 108 minus 18. It's not 15. It's 90. Okay, so once you get to the point where you get two differences that are not the same, we know this is not arithmetic. So that one we can check off the list. Now let's do a similar check with the geometric version. Here, rather than doing the bottom minus the top, it's always going to be bottom divided by the top. So I'm actually going to write that in here real quick. So for arithmetic, the check is bottom minus top, and you want to see if you get the same difference each time. For geometric, the check is bottom divided by top, and see if you get the same number each time. So let's do that here. 18 divided by 3 means that we had to multiply by 6. Let's do the same check now for the next line. So 108 divided by 18, that is also 6. Here's the thing though. You've got to keep checking. You've got to check that difference, or that ratio rather, for all the terms you have. So now take 648 divided by 108. That also gives me a multiplier of 6. And then lastly, 3,888 divided by 648. Again, it's a multiplier of 6. If all of these numbers are the same, if you've multiplied by the 6 each time, then you have a geometric sequence. One thing I want you to notice is that with the geometric sequence, the numbers get very big very fast if your multiplier is a larger number, and 6 is really a larger multiplier. So we went from 3 all the way up to almost 4,000 in just 5 steps. Okay, I'd like you to try this next one. While I get my table set up, you can go ahead and start checking your common differences, checking for common ratios, and we'll check in just a bit. Okay, again, I'm going to make my list of terms. 1, 2, 3, 4, so 5 terms again. And then their value. So if you haven't done your checking at this point, do a quick pause because I'm going to start doing my checking. All right, checking arithmetic first. Just going to do bottom minus top. So -3 minus -5. So -3 minus -5 is 2. Okay, that makes sense. To go from -5 up to -3, you had to add 2. So we did a plus 2. From -3 to 0, that one I can kind of do in my head, right? I hope you can too. From -3 to 0, you'd have to go up 3 spots. Okay, we're not, and from here you're adding 4. Yeah, we're not adding the same number each time. In order to be an arithmetic sequence, these numbers that you add have to be the exact same thing each time. So that's not happening. So not arithmetic. Let's check for geometric. So same thing, but with division, bottom minus top. So let's check -3 divided by -5. Let me get this second. Ooh, let's just do this whole thing over. So -3 divided by -5. Okay, so 0.6. So to go from step 1 to step 2, we'd have to multiply by 0.6. For the next one, to go from -3 to 0, well, if you get 0 as a result, that means you multiplied by 0. These are not the same multiplier. Therefore, this is not a geometric sequence either. So if it's not arithmetic, and if it's not geometric, then it's got to be neither. Now, here's a quick way to spot whether a sequence is potentially geometric. If it's got a 0 in it, and then numbers after it are not 0, it can't be geometric. Because 0 times any number is going to just keep giving you 0 after 0 after 0. So we can keep that in mind. All right, just a couple more here for practice. Same thing. Fractions. So start doing your work, and then we'll check in a bit. Okay, let's do our arithmetic check. First, take bottom minus top, see if we get the same number each time. I'm going to use my handheld calculator. So 5 halves minus 2 means that we had to add on a 0.5. For the next check, 3 minus 5 over 2. I got 0.5 again. That's a promising sign. 7 over 2 minus 3. So again, doing a bottom minus top. 0.5 again. Okay, so far, 3 of them are working. We got to check them all, though. So then 4 minus 7 halves. 0.5 again. Okay. So yes, because we are adding on the same number each time, the common difference is 0.5, we have an arithmetic sequence. I wanted that to be, there we go. Next up. Ooh. Okay, some decimals. Nothing changes with decimals. I also noticed they're negative. Nothing changes if they're negative. We're going to do the exact same process. Okay, let's check arithmetic first again. So do a bottom minus top. Now be very careful of your signs here. So we're doing a subtraction of negatives. So when we type in, I want to get my numbers right here. So I'm going to do bottom minus top, negative 14.6 minus negative 15.8. Negative 14.6 minus negative 15.8 gives me a common difference of 1.2. Okay. So to go from term 1 to term 2, we had to add on 1.2. Next up, do the second bottom minus top. I'm going to use my handheld calculator this time. So negative 13.4 minus negative 14.6. Oh, I got a 1.2 again. Check the next one, bottom minus top, negative 12.2 minus negative 13.4. Got a 1.2 again. And I can also tell by looking at this one that same thing is going to happen. Negative 12.2, if you add on 1.2, you're going to get less negative. And the 0.2 will cancel down to a 0.0. So yeah, plus 1.2 again. So we are adding, the same number each time. This is another arithmetic sequence. Very, very nice. Okay, we are in the home stretch. Let's take a look at these last two. Same procedure. Now, before you start doing your checks, just take a look at things and let's notice some patterns. Pattern 1. You see how we're switching between positive and negative each time? I can tell you from experience, and if you think about it, I think you'll understand why. Arithmetic sequences don't do that. They either stay negative the whole time, stay positive the whole time, or are negative and then switch to being positive forever, or are positive and then switch to being negative forever. They don't go back and forth. So this won't be arithmetic. I don't even want to check it. Just disable a little time. Also notice that the numbers are getting pretty big, pretty quick. Those are both switching the positives and negatives and the numbers getting big. Those are both indications this might be geometric. So let's check that first. We'll do divisions as our first check. So bottom divided by top. Negative 8 divided by positive 2 means that we had to multiply by negative 4. 32 divided by negative 8. Well, 32 divided by 8 is 4. They're different signs, so it's going to be a negative again. Now 128 divided by 32, it's going to turn out to be 4 again, but never hurts to check with a calculator. Sure enough, a negative 4 when you do negative 128 divided by 32. And then let's just check the last one. So 512 divided by negative 128, got a negative 4 one more time. So because we're multiplying by the same number each time, yes, this is geometric. And the common ratio is that negative 4. I think, I haven't been highlighting here. Let's highlight to catch up. Bam, bam, bam.